Welcome to While We Were Distracted, the podcast where we explore topics that often get overshadowed in the rush of daily life. Please take a moment to like and subscribe. It really helps.
Okay, so imagine you're out in the wilderness, totally lost,
Right.
and you pull out your compass, thinking it'll point you north, but instead it goes totally haywire. It's sending you in the opposite direction.
Oh, that's got to be unnerving.
Totally.
Hmm.
And the crazy thing is, that's kind of what's happening with Earth's magnetic field right now. It's not as stable as we might think.
Right. Right.
So today we're diving deep into this whole magnetic mystery.
Sounds fascinating.
Yeah, it really is. We found this article that's got us all intrigued.
Oh, what's it about?
Well, it talks about how the magnetic North Pole is like on a wild road trip.
Mm.
And get this, it's heading straight for Russia.
I've heard a little about that.
Yeah, so we're going to figure out why that's happening, how fast it's moving, and what could happen because of it.
Okay, yeah, the consequences are pretty wild from what I remember reading.
Exactly. And one thing that really caught my eye was the article mentions that these magnetic poles, they flip every 300,000 years.
Right. It's like a magnetic flip-flop.
Yeah. But here's the thing. The last flip was like 780,000 years ago.
Oh, wow. Yeah, that is a long time.
So does that mean we're overdue for a magnetic switcheroo?
Well, it certainly seems like Earth's magnetic field likes to keep us guessing. And you're right, the magnetic North Pole is moving towards Russia pretty quickly, too. About 30 to 37 miles a year.
Whoa, hold on. 30 to 37 miles a year. That's like a whole football field every day.
It is. It's moving a lot faster than most people realize.
Okay, wow. Before we go any further, can we just clarify something for everyone?
Sure, what's up?
This article keeps mentioning magnetic north and geographic north. Are those the same thing?
Good question. It's an important distinction. Think of it this way. Geographic north is fixed, like it's literally the top point of our globe.
Okay, makes sense.
But magnetic north, well, that's determined by the Earth's magnetic field. It's always in flux.
Oh, I see.
And that field, it actually comes from the flow of molten iron in the Earth's core.
Wait, so deep inside our planet, there's like a giant ocean of molten iron.
Basically.
Wild. The article called it a giant cup of tea sloshing around.
Haha, yeah. It's a good way to visualize it, even if it is a bit oversimplified.
Right. But how does that molten iron, actually create a magnetic field? That sounds crazy.
It really is pretty amazing. It's a phenomenon called the dynamo effect.
Dynamo effect.
Yeah, so picture all that molten iron swirling around deep down.
Okay, I'm picturing it.
As it moves, it generates electric currents.
Oh, okay.
And those currents create this massive magnetic field that surrounds the entire planet.
So it's like Earth has this huge invisible force field.
Okay.
And it's all thanks to a bunch of molten metal spinning around.
Exactly.
That's incredible.
It is, isn't it? It's mind-blowing when you think about it.
So this article also mentioned that this whole magnetic shift can actually mess with our compasses and GPS systems. How does that work?
Right. Well, think about it. A lot of our navigation systems rely on Earth's magnetic field.
Right. To orient themselves.
Exactly. So as the magnetic North Pole moves, those calculations become less and less accurate.
Oh, that makes sense.
That's why there's something called the World Magnetic Model. It's a constantly updated map of Earth's magnetic field.
So we're constantly having to adjust our understanding of where magnetic north really is.
Precisely. Keeps things from going haywire.
Okay, so something happening deep inside our planet can actually throw off our phones. That's crazy.
Yeah. It really shows how connected everything is,
Totally. But let's talk about this whole pole flip thing. The article says that when the poles flip, the magnetic field basically shrinks to zero.
Yeah, there's a period of significant weakening.
Hold on. Zero magnetic field. Wouldn't that leave us totally exposed?
Well, it's not quite like flipping a switch. It wouldn't happen overnight. The field would weaken gradually, maybe over hundreds or even thousands of years.
Oh, okay. So not an instant apocalypse then.
Not instant, no.
Yeah, it's good to know. But wouldn't a weaker magnetic field still have, some serious effects?
Definitely. It would mean more solar radiation reaching Earth.
Oh, that doesn't sound good.
But don't worry, we're not completely reliant on the magnetic field for protection. Our atmosphere also plays a role in shielding us from radiation.
Oh, right, the atmosphere. I forgot about that.
It's a multi-layered defense system.
So we wouldn't be completely defenseless.
Exactly.
But even with the atmosphere helping out, wouldn't a weaker magnetic field still affect us? I mean, this is sounding like a sci-fi disaster movie.
It would definitely be a strange time. Imagine our technology would be much more vulnerable to solar storms.
Oh, no, that means like blackouts, right? And no internet.
Potentially, yes. Widespread communication outages, too. And even with the atmosphere, there'd be an increased risk from radiation exposure.
Ugh, okay, that's not great.
But there's also a potential upside.
Really? What upside?
Well, we'd see some incredible auroras, like all over the globe.
Whoa, so like a global light show?
Exactly.
Huh. Okay, maybe a weaker magnetic field wouldn't be all bad.
But if we're overdue for a flip, shouldn't we be worried?
Wow.
Can scientists even predict when the next one might happen? Unfortunately, with our current understanding, predicting the exact timing of a pole flip is impossible. The Earth's magnetic field is just too complex.
Oh, okay.
And the changes we're seeing right now, they're actually considered normal.
So no need to panic and build a bunker just yet.
Not yet, no.
Yeah.
But it is a fascinating area of research.
It really is. So if the field is so complex, how do scientists even begin to study it?
That's a great question. They've developed some amazing tools and techniques. One of them is paleomagnetism.
Paleomagnetism, what's that?
It's like having a time machine for Earth's magnetic field.
Wait, really? Tell me more.
It's all about looking back in time. You see, when molten lava cools and hardens into rock,
Right.
tiny magnetic minerals inside it align themselves with the Earth's magnetic field at that exact moment.
Yeah.
It's like taking a snapshot of the magnetic field from millions of years ago.
So we can look at these ancient rocks and see what the magnetic field was like way back then.
Exactly. It's like Earth keeps its own magnetic diary.
Wow. That's incredible. So we can see how the field has changed over time.
Precisely. We can track its movements, its flips, everything.
That's amazing.
Yeah.
But what about the present? Have scientists discovered any other, strange or unexpected things about the magnetic field recently?
Oh, absolutely. One of the most fascinating discoveries has been these things called magnetic anomalies.
Magnetic anomalies, what are those?
They're regions where the magnetic field is much stronger or weaker than expected.
Oh, so like hot spots and cold spots.
Exactly. A good example is the South Atlantic anomaly. It's this huge area where the magnetic field dips really close to Earth's surface.
A weak spot in Earth's magnetic armor. That sounds kind of scary. Why should we care about that?
Well, think about satellites. When they pass over this anomaly, they're exposed to much higher levels of radiation.
Oh, so it could mess with their electronics.
Definitely. Your GPS could go haywire, communication satellites could malfunction, all because of this strange magnetic dip.
Wow. So something happening deep within our planet could mess with our GPS. That's wild. It really shows how crucial it is to understand all these systems.
Right, absolutely. The Earth's magnetic field, it's more than just a shield. It impacts everything from weather patterns to animal navigation. And these anomalies, they're still a big puzzle for scientists.
It's like Earth has this giant invisible puzzle, and we're just starting to figure out how the pieces fit together.
Exactly. And these anomalies, they're like these missing pieces holding clues to the bigger picture.
This is so cool. But speaking of powerful forces, I got to ask.
Yeah.
What about earthquakes and volcanoes? Are they connected to pole shifts?
Ah, that's a popular question. It's a dramatic thought, isn't it? But so far, scientists haven't found any real evidence to link pole flips with more earthquakes or volcanic eruptions.
Okay, so no need to worry about a disaster movie scenario just yet. But I am curious. What would a pole reversal actually be like? Would it be sudden or more a gradual thing?
Well, from what we can tell by studying ancient rocks, pole reversals seem to happen over long periods, like hundreds, maybe even thousands of years.
So no instant compass chaos or anything?
Nope. It's more like a slow, gradual shift. But during this transition, the magnetic field wouldn't just weaken, it could become way more complex.
Oh. What do you mean by complex?
Well, instead of having a clear north and south, we might have multiple magnetic poles all over the place. Imagine a compass with several needles all pointing in different directions.
Whoa, multiple poles. That would be so confusing. Would that affect animals too?
Absolutely.
I mean, a lot of them use the magnetic field to migrate and navigate, right?
Exactly.
Yeah.
Birds, whales, tons of creatures rely on it. A pole reversal would be like their GPS suddenly went haywire.
Wow.
Yeah.
That's incredible to think about.
Yeah.
So the effects wouldn't just be on our technology, it could impact entire ecosystems.
Exactly. It's a truly global event.
You mentioned earlier that the last reversal was almost 800,000 years ago. How do scientists even know that? Was there, like, a magnetic field historian back then?
Haha. No magnetic historians that we know of, but that's where paleomagnetism comes in. Remember, scientists can study the magnetic signatures in ancient rocks and sediments.
Oh yeah, it's like reading Earth's magnetic diary.
Exactly. And by doing that, they can reconstruct the history of the magnetic field going back millions of years. It's like deciphering a secret code hidden inside the Earth.
That is so cool. So we can look back in time and understand these ancient magnetic events.
We can. It's amazing what we can learn from those rocks.
It really is. But besides those reversals and those anomalies, are there any other, like, weird or unexpected things scientists have discovered about the magnetic field?
Oh, there are always new discoveries. For example, did you know that the Earth's magnetic field isn't perfectly symmetrical?
Really? I thought it was like this perfect sphere of influence.
Nope. It's actually a bit lopsided. The magnetic field is weaker in the Western Hemisphere than in the Eastern Hemisphere.
Huh, that's weird. What causes that?
That's another one of the magnetic field's many mysteries. Scientists think it might be because of the way the molten iron flows in the Earth's core.
Oh, so it's like trying to understand the currents in a giant invisible ocean.
Exactly. It's incredibly complex.
This whole conversation is blowing my mind. So the Earth's magnetic field is this incredibly complex and dynamic system.
It is.
And we're just starting to understand it, right?
Right. And the more we learn, the more we realize how much we still don't know.
Okay, so we talked about the South Atlantic anomaly, where the field is weaker. Are there any places where it's, like, stronger?
Definitely. There are regions where it's so strong that it actually deflects those charged particles from the sun, or called radiation belts.
Radiation belts. That sounds kind of intense.
They can be dangerous to satellites and astronauts,
Oh, right, because of the radiation.
but they also help protect us from that same radiation.
So it's like a double-edged sword.
Exactly. It's all about balance.
Man, this magnetic field is full of surprises.
It is, and that's what makes it so fascinating to study.
You know, this whole conversation has made me realize how much we take the Earth's magnetic field for granted.
Right. It's easy to forget about it since we can't see it.
Yeah, but without it, life on Earth would be impossible.
Totally. We depend on it more than we realize.
It just goes to show how connected everything is, from the molten iron in Earth's core to the satellites way up in space.
It's all linked. It makes you appreciate the bigger picture, doesn't it?
Definitely. It's amazing.
It is.
So, back to this whole pole flip thing. We've talked about how it could affect technology,
Right.
but what would it actually feel like for us during that transition? Would we physically feel the magnetic field weakening?
That's a great question. To be honest, scientists are still debating that.
Oh, really?
Yeah, we don't know for sure. It's possible we wouldn't feel anything too dramatic.
Okay, so no sudden floating sensations or anything like that.
Probably not. Gravity would still be holding us down.
Good point. But you mentioned earlier that we'd be more exposed to solar radiation. Would we see any visible effects from that, besides more auroras?
It's possible. Some scientists think we might see changes in weather patterns.
Oh, really?
The magnetic field influences how the solar wind interacts with our atmosphere. And who knows, maybe we'd even see some strange atmospheric phenomena that we've never seen before.
Whoa, that's kind of exciting.
It is. There's still so much to discover about the magnetic field.
It sounds like a time of challenges, but also exciting possibilities. But for now, at least the changes we're seeing are considered normal.
That's right. And it's important to remember that Earth's magnetic field has always been in motion.
Always changing, huh?
Always changing.
So what about the South Pole? Is it moving too?
Oh, definitely.
Is it doing its own magnetic dance?
It is. The South Magnetic Pole is shifting as well, although not quite as dramatically as the North Pole. It's currently off the coast of Antarctica, drifting westward.
So both poles are on the move. It's like they're doing a magnetic tango.
Exactly.
But how do scientists even study something like a magnetic field? I mean, you can't see it, you can't touch it.
Right, it's invisible. But that doesn't mean we can't study it. We have some amazing tools.
Like what?
Well, one of the main tools is the magnetometer.
A magnetometer, what's that?
It measures the strength and direction of the magnetic field. We have them all over the globe, constantly monitoring the Earth's magnetic pulse.
Whoa, so we have these magnetic sentinels all over listening to the Earth.
Pretty much. And by combining the data from all these magnetometers, scientists can create these detailed maps of the magnetic field, and we can see how it changes over time.
So we're constantly updating our understanding of this invisible force.
We are. It's a dynamic system, always in motion.
That's fascinating. But I remember you mentioned satellites earlier.
Right. Satellites are also key.
What can they see that the ground-based magnetometers can't?
Well, satellites give us a global perspective. They help us understand how the Earth's magnetic field interacts with the solar wind.
Oh, right, the solar wind. that constant stream of charged particles from the sun.
Exactly.
So how do satellites help us study that?
There's this amazing mission called Swarm.
Swarm, like a swarm of bees.
Haha, kind of. It's actually 3 identical satellites flying in formation.
3 satellites, all working together.
Yep. And they're measuring the magnetic field with incredible accuracy.
It's like having 3 eyes in space, watching over our planet. What kind of information can we get from that?
Well, they give us these incredibly detailed 3D maps of the magnetic field.
Oh, wow. 3D maps.
We can see how it changes over time, how it interacts with solar radiation, and even how it's influenced by what's happening deep inside the Earth.
That's incredible. It's like we're peeling back the layers of this invisible shield, seeing how it all works.
It's amazing what we can learn with these satellites.
It really is.
Yeah.
But it's not just about observation, right? You mentioned computer models earlier.
Right. Computer models are crucial too.
How do they help us understand the magnetic field?
Well, they're like virtual laboratories.
Virtual laboratories.
Yeah, scientists can use them to experiment with different scenarios and test their theories.
Oh, okay. That makes sense.
These models can simulate all the complex stuff happening in the Earth's core, like the flow of the molten iron, the planet's rotation, all sorts of factors.
It's like having a mini Earth inside a computer.
Pretty much. And by comparing the results of these simulations with real-world observations from magnetometers and satellites, scientists can really fine-tune their understanding of the magnetic field.
That's amazing. So we're using all this technology to unravel the mysteries of this invisible force.
We are.
It's mind-blowing.
It really is.
But we've talked a lot about natural processes that shape the field. What about us? Could human activities be affecting it too?
That's a really important question. And yeah, scientists are definitely looking into that. Some studies suggest that large-scale mining operations could actually be changing the magnetic field locally.
Really? So what we do on the surface could be impacting something deep inside the Earth.
It's possible. It really highlights how interconnected everything is.
Totally. It's also kind of scary, though. Like, are we messing with something we don't fully understand?
Well, that's why it's so important to study these things.
Right. We need to understand the consequences of our actions.
Exactly. We have responsibility to learn more about the magnetic field and how we might be impacting it.
For sure.
It's not just about protecting ourselves, but about ensuring a healthy planet for future generations.
Well said. But on a lighter note, are there any theories out there about how we could use the magnetic field to our advantage?
Like magnetically powered spaceships.
Yeah. Wouldn't that be cool?
It would be incredible. There have been some ideas about that kind of thing, like using the magnetic field for energy or propulsion.
Really?
Yeah, but they're still very theoretical at this point. The magnetic field is powerful, but it's also incredibly complex.
Oh, right.
We still have a lot to learn before we can start manipulating it on that scale.
Okay, so no magnetic hoverboards just yet. But it's fun to think about the possibilities.
Yeah.
So back to the magnetic field as a shield.
Right.
What are the biggest threats to this shield?
Well, as we talked about, the sun is a big one.
The sun.
Remember the solar wind?
Oh, yeah, that constant stream of particles.
The magnetic field deflects most of it, which protects us.
Okay, that's good.
But sometimes the sun releases these massive bursts of energy like solar flares and coronal mass ejections.
Oh, the Earth.
Those can overwhelm the magnetic field.
Oh,
And when they hit Earth, they cause geomagnetic storms.
geomagnetic storms. That sounds intense. What happens during those?
A lot of things. They can disrupt power grids, mess with satellite communications, even make GPS systems go haywire.
Oh, seriously? So that's why we need that magnetic shield.
Exactly. It protects us from some pretty powerful stuff.
Okay, so the sun is one threat. What about human-made threats? You mentioned earlier that things like mining and electromagnetic radiation could be affecting the magnetic field. Are there any other things we should be worried about?
Yeah, there's always the risk of accidental damage.
Accidental damage, like what?
Things like nuclear explosions or large-scale electromagnetic pulses.
Oh, wow. Yeah, those would be bad.
They could disrupt the magnetic field, maybe even weaken it.
That's scary.
It is. It really highlights how important it is to be responsible.
Yeah, we need to understand what we're doing and how it could affect the planet.
Exactly. It's about protecting our planet for future generations.
Well said. This whole conversation has been amazing. It's crazy to think about this invisible force that protects us
It really is incredible, isn't it?
and plays such a huge role in so many things on Earth.
Absolutely. It affects everything from weather patterns to animal migrations.
Oh, and speaking of amazing things, we can't forget about the auroras.
Ah, yes. The Northern Lights.
They're so beautiful.
They are.
And they're a reminder of how powerful and majestic the Earth's magnetic field is.
Definitely. The auroras are a visible manifestation of all those invisible forces at play.
It's like a cosmic light show.
It is a beautiful reminder of the connection between Earth and the sun.
So next time we see an aurora, we should remember that it's not just a pretty light show. It's a testament to this incredible shield that protects us.
Exactly. And it's a reminder that we need to take care of this planet.
Totally. We have a responsibility to understand and care for Earth and all its intricate systems.
Well said. It's about appreciating the wonder, acknowledging the challenges, and embracing the responsibility we have to protect this little blue planet we call home.
That's beautiful. It's the perfect way to sum things up. Thanks for joining us on this magnetic journey.
My pleasure. It's been a fascinating conversation.
And remember, everyone, stay curious. Keep exploring.
Yeah, it's a common thought for sure. It does sound kind of scary, but honestly, scientists haven't found any proof that those things are connected.
Okay, so no need to stock up on canned goods just yet. But I'm still kind of curious, what would a pole flip actually look like? Like, would it be sudden or more of a gradual thing?
Well, based on what we've seen in those ancient rocks, it seems like pole reversals happen over a pretty long time, maybe hundreds or even thousands of years.
Oh, so it's not like, bam, the compass goes crazy.
Nope, more like a slow, graceful shift. But during that time, the field wouldn't just weaken, it could actually get way more complex.
Complex, how so?
Well, instead of having a clear north and south pole, we might end up with multiple magnetic poles.
Wait, multiple pole, like all over the place.
Yeah, imagine a compass with like 5 needles all pointing in different directions.
Whoa, talk about confusing. That would make navigation a nightmare. Would that mess with animals too?
Oh, absolutely.
A lot of animals use the magnetic field to migrate, right? Like birds and whales.
Exactly. They use it like their own internal compass. So during a pole reversal, it'd be like their GPS suddenly started giving them bad directions.
Wow, that's crazy to think about. So this wouldn't just affect our technology, it could mess with entire ecosystems.
Yeah, it's a pretty big deal. A truly global event. You mentioned earlier that the last reversal was like 800,000 years ago. How do scientists even know that? Did they have like magnetic field historians back then?
I can't picture that.
No magnetic historians that we know of. But remember paleomagnetism? That's how we know.
Oh yeah, that's where scientists study the magnetism in those old rocks, right?
Exactly. They can actually look at the magnetic signatures in those rocks and sediments and figure out what the magnetic field was like way back then.
It's like deciphering a secret code buried in the Earth itself.
It is. And by doing that, they can create a history of the magnetic field going back millions of years.
That's incredible. So we can actually look back in time and understand these ancient magnetic events.
We can. It's amazing what we can learn from those rocks. But besides those reversals and the anomalies we talked about before, are there any other like weird or unexpected things that scientists have discovered about the magnetic field?
Good question.
Mm-hmm.
There must be.
There are always new discoveries. For example, did you know that the Earth's magnetic field isn't perfectly symmetrical?
Really? I always thought it was like this perfect sphere of magnetic energy.
Nope. It's actually a little lopsided.
Lopsided.
How so? The magnetic field is weaker in the Western Hemisphere than in the Eastern Hemisphere.
Huh. That's so strange. Why is that?
That's a great question. And it's another one of those magnetic mysteries. Scientists think it might have something to do with how the molten iron flows in the core.
Oh, so it's like trying to understand the currents in this giant invisible ocean of molten metal.
Exactly. It's incredibly complex, and we're still trying to figure it all out.
This whole conversation has been mind-blowing. So the Earth's magnetic field is this super complex system that's always changing.
It is. And the more we learn, the more we realize how much we still don't know.
Well, we talked about the South Atlantic anomaly where the field is weaker. Are there any places where it's stronger than usual?
Oh, yeah, for sure. There are some areas where the magnetic field is so strong that it can actually deflect the path of those charged particles from the sun.
Really?
These areas are called radiation belts, and they can be pretty dangerous for satellites and astronauts.
Oh, right, because of all the radiation.
But those same radiation belts actually help protect us down here on Earth.
So it's like a double-edged sword.
Exactly. It's all about balance. That's one of the things that makes studying the magnetic field so fascinating. It's this constant interplay of forces, a delicate dance between protection and potential disruption.
It's kind of poetic when you think about it, this invisible force that both protects us and could potentially cause problems.
I know, right? It really makes you appreciate the complexity of nature.
This whole conversation has made me realize just how much we take the Earth's magnetic field for granted. It's like it's always there, quietly working in the background, protecting us.
It's easy to forget about it until something goes wrong. But without it, life on Earth as we know it wouldn't even be possible.
Totally. It's a good reminder of how connected everything is and how important it is to understand these systems.
It is, and how our actions can impact them. We have a responsibility to learn more about the magnetic field and do what we can to protect it.
Okay, so back to this pole flip idea. We talked about how it could affect our technology and even animals.
Right.
But what would it actually feel like for us during a pole reversal? Would we feel the magnetic field getting weaker?
That's a good question. And to be honest, scientists are still trying to figure that out.
So we don't know for sure.
Not yet. But it's possible we wouldn't feel anything too crazy. I mean, gravity would still be holding us down.
Okay, so no floating around or anything like that?
Probably not. But remember we talked about how a weaker magnetic field would mean more solar radiation reaching Earth?
Right. So besides more auroras, would there be any other visible effects from that?
Maybe. Some scientists think we could see some changes in weather patterns. Yeah, you see the magnetic field influences how the solar wind interacts with the atmosphere. So a weaker field could mean some unpredictable weather.
Huh. So we might get some crazy storms or something.
It's possible. We might even see some strange atmospheric phenomena that we've never seen before.
Wow. That's kind of exciting and a little scary at the same time.
Yeah,
It's like we're entering uncharted territory.
it is. There's still so much to learn and discover about the magnetic field and how it affects our planet.
For now, at least, it's good to know that the changes we're seeing are still considered normal.
That's right. The Earth's magnetic field has always been in motion. It's a dynamic system that's constantly changing and evolving.
Speaking of motion, I'm curious about the South Pole. Is it doing its own magnetic dance as well?
Yes, the South Magnetic Pole is also shifting, although not quite as dramatically as the North Magnetic Pole. It's currently off the coast of Antarctica, drifting westward.
So both poles are on the move,
Mm-hmm.
just in different directions. It really is like they're doing their own magnetic tango.
Exactly. But while we're on the topic of poles, how exactly do scientists study something as intangible as a magnetic field? What are the tools and techniques they use to unravel its secrets?
Well, one of the main tools is called a magnetometer.
Magnetometer. That sounds complicated.
It's not as scary as it sounds. It basically just measures the strength and direction of the magnetic field.
Yeah.
And we have these magnetometers stationed all around the world.
So they're like little magnetic listening posts?
Yeah, you could think of it that way. They're constantly monitoring the Earth's magnetic pulse.
So we have this global network of sensors keeping tabs on this invisible force field.
Exactly. And by combining all the data from these magnetometers, scientists can create these really detailed maps of the magnetic field.
So we can see how it changes over time.
Precisely. We can track its movements, its fluctuations, everything.
That's pretty cool. But I remember you mentioned satellites earlier. What role do they play in all of this?
Ah, yes. Satellites give us a different perspective. Literally,
What do you mean? Well, they're up in space, so they can see the big picture of how the Earth's magnetic field interacts with the solar wind.
oh, right, because they're outside of the magnetic field.
Exactly. They have a unique vantage point.
That makes sense.
Mm.
Are there any specific satellite missions that are focused on studying the magnetic field?
Oh, yeah. There have been some amazing missions.
Yep.
One that comes to mind is the European Space Agency's SWARM mission.
Swarm, like a swarm of bees.
Haha, kind of.
Mhm.
It's actually 3 identical satellites flying in formation.
3 satellites all working together.
Yep. And they're measuring the magnetic field with incredible precision.
Wow. So it's like having 3 eyes in space constantly watching over our planet.
Exactly. And the data they collect is incredibly valuable.
So what kind of insights can we gain from this swarm mission?
Well, for one thing, they create these incredibly detailed 3D maps of the magnetic field.
3D maps. That's pretty high tech.
It is. We can see how the field changes over time, how it interacts with solar radiation, how it's influenced by things happening deep within the Earth.
Yeah.
It's amazing.
It really is. It's like we're getting a glimpse into this invisible world that surrounds us. But it's not just about observing, is it? You also mentioned computer models earlier. How do those fit into the picture?
Computer models are super important. They're like virtual laboratories.
Virtual laboratories. How does that work?
Well, scientists can use these models to simulate different scenarios and test their theories.
So it's like running experiments, but inside a computer.
Exactly. They can tweak different variables and see how it affects the magnetic field.
That's so cool. What kind of things can they simulate?
They can simulate the flow of molten iron in the Earth's core, the planet's rotation, all sorts of things. It's like having a mini Earth inside a computer.
And by comparing those simulations with the real-world data from the magnetometers and satellites.
Exactly. Scientists can refine their understanding of how the magnetic field works.
It sounds like there's a lot of really cool research happening in this field. But we've talked a lot about the natural processes that shape the magnetic field. What about our role in all of this? Could human activities be impacting this invisible shield that surrounds us?
That's a great question. And it's something scientists are definitely looking into. There's growing concern that some of our activities could be affecting the magnetic field.
Like what kind of activities?
Well, for example, some studies have shown that large-scale mining operations can actually alter the magnetic field locally.
Wow. So what we do on the surface can have an impact on something so deep within the Earth.
It seems that way, and it's a reminder of how interconnected everything is.
Totally. There's also all the electromagnetic radiation we're generating from our electronics. Could that be having an effect too?
That's another area of active research. Some scientists believe that all that radiation could be having a cumulative effect on the magnetic field.
It's like we're adding our own little magnetic signatures to the planet's already complex field.
In a way, yes. And it highlights the importance of understanding these systems and being mindful of our impact on them.
Definitely. It's not just about protecting ourselves, but about ensuring a healthy planet for future generations.
Well said. It's about understanding our place in this vast, interconnected web of life.
Well, this has been an incredible journey. I never realized how much there was to learn about the Earth's magnetic field.
It's truly fascinating, isn't it?
It is. It's amazing to think about this invisible force that surrounds our planet, protecting us from the dangers of space, and playing such a crucial role in so many processes here on Earth.
It's a reminder that we're part of something much larger than ourselves.
Absolutely.
Yeah.
And it's a reminder that we need to keep exploring, keep learning, and keep asking questions.
I couldn't agree more.
Well, thanks for joining us on this magnetic adventure.
It was my pleasure.
And everyone listening out there, stay curious and keep exploring the wonders of our universe.
Please take a moment to like and subscribe. It really helps.